Hello everybody. Today we're going to be creating a graphing calculator using Python. Now as you can see here I have the scipy.org um, website opened up. It's basically showing right here all of the functions of NumPy which we're going to be able to use in our calculator. So we're going to also be able to graph with it. So I'm not really planning to do any UI kind of thing, but if you want to do that, well, I guess you could do it, but I'm not going to be telling you how to do that. I'm just going to be creating a simple, input output kind of interface for the user. Also, so if you don't have any Python experience, I suggest you know, try to go over what, NumPy is and matplotlib, which is what we're going to be using to graph, and, you know, research about Python in order to understand this. So, without further ado, let us begin. So first create a Python file. I'm gonna name it calc.py, and in there I'm gonna import two libraries. One is going to be NumPy and P, and import matplotlib.pyplot as plt. Now if you don't have these two libraries, you have to go to the command prompt in cmd, um, or terminal if you're on Mac, and say pip install whatever the library name is. For example, NumPy, or it's py minus m, python minus m pip install, something like that. You should probably go search for it. After you're done doing that and know that it's working, let's create two functions, cmode and gmode. So first of all, cmode is basically going to be our basic calculator mode. So we're basically going to be, taking in input and then throwing out the result output. So it could be anything. It could be about sine, cos, tan, as I said before. Um, so we're not really going to be coding for an actual, you know, you're not going to be, recognizing sine and recognizing the plus and the minus and trying to, saying, say, add that if it's equal to that. We're actually going to just take advantage of the Python interpreter, which basically is a calculator. So I'm just going to say, I'll explain that to you after when we get there. We're going to give an indication saying calculations mode so that the user knows that they're in calculations mode. And then we're going to create a variable called prob. And, oops, just create prob and give it a value of a string, I guess, without anything in there. We're also going to say while prob is not equal to q, so in order to run this while loop, we're going to have to use prob, because prob is basically the problem, and it's going to get input, and if the user says q, that means quit. So before we run the loop, we need to, initialize the variable. I think there's a better way of doing it. I'm not sure what it is. It's what I used. Then we're going to create try and accept. And we're going to say print enter problem. Okay. Then we're going to take an input. Right. Now, next part is kind of tricky. So we're going to say print eval, which is basically evaluate bytes. Ord p for p in prob. Okay, so it may look kind of weird to you, but let me explain. So essentially what ard is doing is that it's returning the each of the Unicode values for every character in prob, so whatever the input is, each of the, then I think it's being converted into bytes, and then it's basically evaluating that with the thing that NumPy's with NumPy imported. So essentially, it's basically like importing NumPy on the Python interpreter, and then saying whatever, like saying 1 plus 1 or whatever calculation. So we're just sending it back and getting the output. Okay, now let's put accept. So if we encounter an error or get something else, we're going to do a quick check. If prob is not equal to q, what we want to say is invalid input, because this is, because it is, because if it's not q or not a problem, it's going to be something else. It's not recognized by the program. You could write something else if you want. That's your choice, as long as it's meaningful to the user. Then we're just going to create another function and give another indication to the user. Call it graph mode. Oops, one, all caps mode. Alright, once we're done doing that, we're gonna say, we're gonna again initialize R2. You really don't need to do, you don't really do often in Python, that is initializing. We're also just gonna say while EQ is not equal to Q. We're gonna do the try thing again, try block, and then say print enter equation. Alright. Once we're done with that, we're gonna say EQ is equal to input. So we're taking a string as input because we want to evaluate it. That's how evaluate works. No numbers, please, or any other types, I think. Then we're going to check if it's Q, since we're taking a string in, and we're going to break it, because the user is basically saying, let's quit. But if not, then we are going to take another variable, which is the range, for the x-axis. Say enter range, 1. Okay, and in there we're going to say r1 is equal to int input. Actually, let's just make that input. And if r1 is equal to q, so again, we initialize it as string, but we need a, an int. So if it is q, because if we just put like int, and then if we check for r1 is equal to q, it's pretty much useless, because it's just going to throw an error and go to the accept and print some other thing that we don't want. So we're just going to take it as string for now, and then we're going to say break. But there's an else statement. The else statement, we're going to say r1 if r1 is equal to int of r1, which means if it can be converted into an int, or it is, as a matter of fact, a number as a string, then actually, sorry, not an if right here, just equal to int of r1. So if it's, otherwise it's just going to go to the invalid input part. So yeah, I hope that makes sense. If it doesn't, try to analyze, or let me explain better. So if, say, the user inputs q, then breaks. If the user inputs a number, then it converts it into a number over here because it's not q. But if the user inputs something else, it's going to go to accept and execute whatever is in there. Now we're going to copy this and paste that right there. Enter range 2. Okay, once we're done with that, we will go to creating our x and y axis. np.array. I believe array is something like they're like matrices. They can store values. If you don't know what matrices are, it's basically like a group of data that is in mathematics. You may want to research, or probably you're familiar with it. Or we could just copy this down. We're going to take the range of whatever the user has inputted. that's going to be R1, R2. Y is equal to eval. We're going to do the same thing again, except this is for the everything in between. R, and that is like for the equation for P in EQ. So like I said before, this is just going to be a little bit different because we're plotting Y. So it's going to calculate all of the values and graph it, but it's just solving the problem again, sending it back, getting this result for each of the, R1 to R2 values. So it's 1 to 10. That's what it's going to, evaluate for. Then we're going to say plt dot plot x, comma y, and we're going to say plt dot show so the user knows what's going on. Except, which is, oh boy, what was that? cpt except, check if it's EQ. As explained before, if you remember, said that if this is not equal to Q, something else. If I don't see if you really need this, but I don't know. You can remove it if you want, but I'm just gonna keep it there for now. Invalid input. Okay, we're done with our main two functions. I'm gonna initialize another variable called mode. Give it null value. Okay, and again, run a while loop and say mode is not equal to Q. What we want to do is print this multi-line statement. Basically, writing a multi-line statement saying 1 is C, which is normal calculations. And by the way, if you're creating UI and everything, I don't think you really need this because this is pretty much just, well, I guess an interface for our thing if you're not creating UI. 3 is going to be, of course, help, which is what we're going to be, coding for now. Not a function, actually, just a small check. An if statement. 4 is going to be Q, which is another Q to exit the whole program. And now we are going to say, we're going to take input for mode, which is equal to input 4. So it doesn't matter whether it's uppercase or lowercase, as long as it's good. It's alright. We're going to say if mode is equal to C. We want to execute C mode. If mode equal to G, execute G mode. And if mode equal to H, for now I'm just going to say we're just going to write two small rules. One would be do not use parentheses while multiplying. And another one would be to put np dot before using any of the numpy functions. Now it's probably going to look a little bit ugly because you're putting np before everything, and kind of confuses the user. The thing is, it's kind of hard to actually, recognize each and every single one. I actually tried it with dictionaries, and then eventually it just started messing up because then you need to start, creating your own, keywords for each of them, because sometimes there is a function with sign, and there's another function that says arcsign, and then it checks whether sign is in sign. Well, sign is in sign. That's also an arcsign, and that messes things up, and that's what we don't want. So I'm just going to keep this over here. If you think there's a good way to do this, definitely, tell it down below, comment section. we'll try to make an edit. I'll also try to put this in GitHub so you could, you know, make your own changes. Probably make a better version of it. This is just source code. And I think we're done with the program. We're just going to save all of this stuff and open up our CMD, command prompt, and we're going to cd, sorry for this, should have set this up earlier. Say pi, see calc.py, great. Yeah, what we're going to do now is we're going to go to normal calculations, and we're going to enter a problem. np.sine of 2 multiplied by np.cos 4. Yay, we got a value. And if you're not familiar with log 2, well, that's a value. And we can do normal things too, like 2 plus 2. Let's get out of that mode. Now let's go to G. What do we want to graph? Let's just graph sine effects for now. We're going to say 2, 1 to 10. Cool, right? That's a graph of sine effects. You could also try to, label everything. I'd like label the x-axis, the equation. This is gonna be cool. I'm not sure. It's your choice. Do whatever you want. If we press Q here, also we're just gonna test out whether it works. So we're gonna see Q over here. That seems to work. So and range 1 and range 2 should also work because it's pretty much the same code. Or we'll just, try to get out. Okay, cool. H prints the help. Oops, sorry. H prints help. Which is, you could write your own rules, better than mine, because mine's kind of vague, I think. And Q to quit. Alright, I guess we're done with our program. I guess that's about it for this video. I hope you learned something new, and I hope there's probably a better way of doing all these things. If you have a solution, probably just, comment it down as a link for a file. I'm not sure. Do whatever you want with this thing. It's your choice. Alright. Come on. Okay. Okay. Hope you learned something cool. Alright. Bye. Bye.